So for this, we're going to solve using the elimination method. We have those 6 steps. The first step is to pick a pair of equations and eliminate a variable. The easiest pair to, what you have to do is think about a variable that's easy to eliminate twice, because that's what you have to do in steps 1 and 2. Notice the variables that have a coefficient of 1 or -1 are the easiest. So I would suggest a y or a z. I'm going to choose to eliminate y, and the way I'm going to do that is I'm going to take the last 2 equations, and by the way, that sound is my dog drinking water, I apologize. And if I add the last 2 equations, they're really thirsty. Notice that y cancels out. I would have 4x, I'd have no more y, I'd have plus 5z equals 15. So now in step 2, what I'm going to do is I'm going to pick another pair of equations and eliminate y again. So in steps 1 and 2, when you're all done, you should have only 2 variables to contend with. I think picking these 2 will be the best pair. Since this is a -3, I need to make this a +3 so that when I add them together, the y's go away. But I can't just make this part a 3. I'd have to multiply everything by 3. So keeping the first equation the same and multiplying the second equation by 3, when I add the equations, notice there's no more y, which is what we want. So in steps 1 and 2, you're going to pick a pair of equations, eliminate the same variable in both steps. Now we want one from 3 variables down to 2. And now we're going to repeat it. We're going to take our results from steps 1 and 2 in step 3 and eliminate another variable. Well, notice 5 and 10 are in the same multiple family, so I'm going to choose to eliminate z. It'd be the easiest. Since this is a +10, I would need to make this into a -10. So what do I multiply this entire equation by to make this into a -10? -2. So multiplying that equation by -2, and then copying down the result from step 2. When I add the equations, the z's are gone. I get 3x equals 15. So in step 4, I'm going to solve for our remaining variable. Notice we get x to be 5. In step 5, we now start to back substitute. You can put your x to be 5 back into either equation where you have 2 variables. You do not want to go back to the top yet, because if you put your 5 in for the x, you would still have 2 variables in that equation, and you don't know how to solve an equation when there's more than 1 variable there. So I'm going to choose this guy right here for my x. I'm going to say 4 times 5 plus 5z equals 15. Again, it does not matter which one you pick. So it'd be 20 plus 5z equals 15. 5z equals -5. So z is -1. I'm going to highlight these as we go. So there's our x, there's our z. And now we have to find our y. So go back to any of the 3 original equations now. To solve for y, I'm going to choose the second one just like before. It does not matter which one you pick. So if I put in 5 for x, if I put in -1 for z, notice I have y plus 7 equals 0. Equals 7, which means y equals 0. Write your answer as an order triple x, y, z, 5, 0, -1. I'm going to leave it to you to do step 6, which is to put it back into all 3 equations. 5, 0, -1 should work just fine.